Hello, everyone, and thank you for joining us for today's webinar. Today, we will discuss how to simplify your container management and legacy application deployment across cloud providers with HashiCorp Nomad. I'd like to introduce you to our presenters today. Rob is our Nomad product manager, and Nick is a developer advocate at HashiCorp. Rob is going to introduce Nomad, and then Nick will take over to show how to provision Nomad across cloud providers with HashiCorp tools and more. Finally, Nick will give a demo, and we will wrap up by answering any questions you'll have on Nomad. I also want to note that this webinar is recorded, and the recording will be made available after post-processing, usually within about a day or two. I'll email it out to all of you. With that, let's go ahead and get started. Take it away, Rob. I think we're just going to get Rob unmuted here. Thanks for your patience.
And do I have control?
Yeah.
To share right now?
You should now.
Yep. Give me 1 second. Okay, hopefully you're all seeing the presentation. One second. Okay, thanks, Amanda. And hello to everybody on the line. So as Amanda mentioned, I'd like to spend a few minutes going over how the HashiCorp product portfolio fits together. And also, I'll give a brief technical overview of Nomad before we jump into Nick's demo. So HashiCorp has been around for almost 6 years. We have found that as organizations move from monolithic applications running on dedicated infrastructure to service-oriented applications running across multiple cloud providers, that there are some common set of challenges that are encountered. So HashiCorp's mission is to enable a consistent set of workflows as organizations make this transition, and to do so with a suite of products that have well-defined scope and are loosely coupled, but elegantly integrate with each other to form a solid/complete solution rather than taking an all-in-one platform type approach. So our 4 primary products, Terraform, Vault, Consul, and Nomad together enable an organization to provision, secure, connect, and run any infrastructure for any application. So I'm going to quickly introduce each of the products at a high level, just in case anybody on the call isn't familiar with the portfolio. Starting from the bottom of the slide, Terraform provides a common infrastructure provisioning workflow across private cloud, public cloud, and external services with built-in dependency management. And using an as-code approach. And then moving up the stack to the sort of security tier, Vault enables a unified secrets management workflow across cloud providers and identity sources. And then moving further up the stack to the development tier, where both Consul and Nomad live, Consul provides a backbone, more or less, that enables an organization to connect, configure, and monitor their services across data centers and regions. So Consul is widely used today for service discovery and dynamic configuration, for example, and you may be familiar with that. Then finally, Nomad enables a common workflow for both container-based and legacy application deployment. And again, like the other products, Nomad does so in a way that elegantly spans both private infrastructure and public cloud providers. So the enterprise versions of the products, they add collaboration, operations, and governance features that help organizations address the challenges that arise as the scale and complexity of their own internal platforms increases. So getting a bit into Nomad itself. So Nomad is HashiCorp's scheduler and application deployment tool. The product niche that it fits into is often referred to as either container management or container orchestration. That plays in the same space as Kubernetes, Mesosphere, and Docker Swarm. It is the newest of the 4 primary HashiCorp products, and was designed first and foremost in accordance with HashiCorp principles. So, Nomad is workflow oriented like the other tools. It's simple and modular, can easily be combined with our other tools to solve the wider challenges, right? So in terms of composability. But in many ways, Nomad's design was also a response to the operational challenges and the lack of flexibility that we've observed with some of the other container management tools. And so at a high level, Nomad's goal is to enable an organization to easily run any application on any infrastructure at any scale with the characteristics that are listed here on this slide. So Nomad is, it's easy to learn. It has a very simple mental model. It's easy to use for both developers and operators. It's also flexible and can be easily integrated into your existing workflows. And when I talk about that, one of the key features that I'm referring to is the fact that although Nomad supports a first-class Docker workflow, Docker is not strictly required, and Nomad can also run your legacy applications in binaries directly, and we'll get into that a bit more. Nomad supports all workload types, so we talk about service workloads, batch workloads, and system jobs there. Nomad's also dead simple to federate across regions and cloud providers, which is a huge advantage, and it's something that can be quite complex with some of the other tools. It's also very easy to scale, and it elegantly integrates with other HashiCorp tooling, and most of those tools are quite popular, as many of you are probably familiar with. And so let's cover how Nomad works at a high level before we turn it over to Nick. So Nomad uses a simple client-server architecture. The servers handle application placement across a set of client nodes, and they optimize for resource efficiency, and they account for the priority and the constraints and some of the other factors that have been defined in the job spec. And so from a workflow perspective, Nomad enables a user to define the deployment requirements for the application, which can then be submitted to any server. And they do so in the job specification, or what we call the job spec. So Nomad's job specification is declarative, and it uses the HashiCorp configuration language, aka HCL, which will be familiar to any Terraform users that may be on the call. So the job spec, it defines the deployment schema for the application, basically, and this includes the task definition, the driver, again, which may or may not be Docker, the image, if that's relevant, the resource reservations for the task, again, the priority, any constraints that need to be defined, and the service registrations, right? So if you're running service-based workloads and you need to register your services with console, that also is contained neatly within the job file, and any other information required to deploy the application, basically. Now I'll go over the job spec in more detail in a few minutes. And so from an operational perspective, Nomad consists of a single binary that can run in either client or server mode. 3 or more servers form a highly available control plane to handle scheduling. So the servers store state internally, and they use a Raft-based consensus protocol for state replication and automatic leader election. So this makes Nomad highly available out of the box. There is no etcd or zookeeper external dependency. And the clients register with the servers. They wait or poll for work to be assigned, and they execute the tasks. And then finally, a single logical cluster defines a region with respect to Nomad's nomenclature or data model, and a region can contain multiple data centers. So again, multiple regions can be easily federated together with a single CLI command. And Nomad natively uses a gossip protocol under the hood for cross-region cluster membership and failure detection. And this partially is what makes it so easy to federate and allows Nomad to natively support that. And work can be scheduled across the region boundary. And as mentioned earlier, Nomad stores and replicates state internally across all servers. This architecture and design enables an optimistically concurrent and parallelized scheduling strategy that can yield thousands of job placements per second. We've shown this both in experimental settings, and it's also been proven in a production setting. And this particular feature is a key advantage for batch processing workloads where that sort of high throughput of job placements might be advantageous. So I'm just going to finish up quickly by running through the job spec in a bit more detail so that you have some context as Nick goes through his demo, and he'll be kind of taking you through a few different job specifications as part of that demo. So a job can be submitted to exactly one region, but can request placement across multiple data centers within that region, right? And so the region and data centers parameters that you see at the top of this slide on the right pertain to that. The job type indicates whether the job is a service, a batch job, or a system job, right? And service jobs are simply jobs that run on every node automatically. So if you were to add additional nodes to a running cluster, those system jobs would automatically just sort of be scheduled onto those new nodes, for example. The group stanza within the job spec defines a series of tasks that should be co-located on the same Nomad client, so at placement time. This is somewhat similar to what a pod represents in Kubernetes, if you're familiar with that. The task stanza, which is nested within the group stanza, defines the individual unit of work, right? So such as a web application or a batch processing task, for example. And that stanza includes the driver. So if you're using Docker, that would be indicated there. And it also includes the image that you'd like to use, as well as the resource requirements for the task, right? So your CPU, your memory, and your network requirements. And so constraints in Nomad, they're what limit placement based on client properties or metadata, right? And they can be specified at the job, group, or task level. So you may have a cluster that has a heterogeneous mix of different types of hardware. In some jobs, you might want to target particular instance types, let's say in EC2, and you'd use constraints to do that. The priority for the job is also specified at the job level. So with respect to scheduling, higher priority jobs will be sorted to the top of the evaluation and planning queues, right? So they get scheduled before the lower priority jobs in a relative sense. The env stanza in the job spec can be used to populate the task's environment before starting. So the key value pairs that are sort of set here will end up as environment variables, right, within the task's environment. The periodic stanza allows a job to be run at fixed times, dates, or intervals. So similar to a cron job, basically, but something you can run across a whole cluster. And the update stanza is what you can use to perform rolling canary-based or blue-green job updates, right, for a particular job as you create new versions of that job, for example. And so updates can be gated on console health checks or task health and automatically reverted. If a deployment were to fail, it can automatically revert back to the previous version. And Nick will be demonstrating updates as part of the demo. And so there are a couple of different ways that Nomad integrates with console. So the service stanza in the job spec can be used to register services and health checks in console automatically, while the template stanza can be used to update configuration files within the task or environment variables based on console KV data. So console has two primary use cases, more or less. One's the service registration and discovery, the other being dynamic configuration, right? And so these two features within the job spec sort of represent the integration for those two different use cases. The second one, the template stanza, uses console template under the hood, if you're familiar with console template. And finally, a Nomad cluster can be automatically bootstrapped if a console deployment already exists. So for example, you wouldn't need to kind of manually orchestrate the joining of the servers or the clients to the servers. If console is there and Nomad's configured to point to it, it'll just sort of automatically bootstrap. And as you add nodes and scale it out, they'll automatically join as well. And then finally, Nomad supports a first-class vault-based workflow for secrets retrieval. So the vault stanza in the job spec allows a task to specify that it requires a token from an existing instance of Vault. So you can specify the policies that should sort of be attached to that token. And Nomad will automatically retrieve a Vault token for the task upon job placement. And finally, I'll add that the template stanza that I pointed out in the last slide, that can also be used in addition to pulling KV data into a config file from console. You can also pull secrets from Vault and render those into configuration files or environment variables using the same mechanism. So yeah, that's the end of the overview. So I will turn it over to Nick.
All right, let me just switch this over. Show my main screen. Okay, cool. Thanks very much, Rob. I'm really pleased you went through that because there would be a whole bunch of stuff that I'm bound to forget. But I'm going to show you some of the things that Rob was talking about and just kind of how easy it is to use Nomad. I got like criticized for using a noisy keyboard last time. So now I'm using a keyboard that I can't type on. So if anybody spots any typing mistakes, it's the keyboard, it's not me. But let's just dive straight into this anyway. Okay, so first thing I want to look at. So Nomad, if you, in terms of the way that you interact with it, you've got 3 different methods. So what you have is a CLI. So I've got a CLI tool. I can check the status of my cluster using the CLI. I can drill down a little bit into that. Nomad status system. And I can drill down even further into that. Lock status. So you've got this kind of like really nice method of working with Nomad and interacting with it as an operator. But instead of using a CLI, what else have you got? Well, we've got a UI. And the UI presents only a read-only view. So you can't run jobs and do things like that through the UI, but it's a pretty sweet way to kind of get that high-level overview of what's going on in your cluster, and I can kind of click through and look at the jobs, and if I want to look at the logs which are running from an individual allocation, then I can do that too. But it doesn't end there, because there is also an API. So all of the methods that are available through the CLI and through the UI are also available through a RESTful API. And this is incredibly useful if you maybe want to build your own tooling around Nomad, or maybe you want to interact with Nomad through Jenkins or another CI process. So let's have a look at creating a job and creating a new deployment. All right, let me just flip to my terminal. So as Rob was explaining, the top level of a job is the job stanza. So I'm just going to add that. I was warning you about this keyboard. So you've got the job stanza. So what I'm saying in this job stanza is that I want to deploy this job to a number of data centers. It takes an array, so you can kind of carve up your Nomad cluster however you want in terms of regions and data centers. I'm just deploying it to DC1, which is just my default. And then I'm going to specify the service. So the service is just a standard job. It's kind of like your microservice. It's not going to be deployed to every node like a system job, and it's not a batch job. So it's probably the most common sort of job type that you'll use. And then there's constraints. So constraints are incredibly useful because constraints allow you to kind of position a job on a particular type of node. So in this example, I'm just deploying to Linux. But that sort of configuration, those attributes are very widespread. I can do things like target CPU cores or particular flavors. Where this is kind of really useful is when you look at Nomad's capability for multi-mode workloads. So I can actually have a Nomad cluster which is comprised of Linux nodes, Windows nodes, I can have Mac nodes, Raspberry Pi nodes. It's really, really flexible. And constraints are very, very useful to be able to kind of manage where a particular job is going to go. So the next level down. So the next level down is the group. So what a group does is it allows you to position tasks together. So a task is a kind of an individual unit of work, And a group comprises of multiple tasks. So for example, if I just quickly take a look at my system job, I have two tasks. I have a task which is statsd, which is just my statsd metrics collector, and I have a reverse proxy. In this case, it's Fabio. And I want those grouped together. So I want both of those deployed every time I deploy the job, and I want them to be positioned on the same node. But the task is where the kind of the real meat is, if you will. So let's have a look at what that looks like. So the task is where you define your driver. So the driver is a number of different sort of options. Let's have a quick look in the docs, but you don't have to just use Docker. You can use Java, you can configure raw binaries, either in an isolated mode or non-isolated. You got the capability of running LXC, QEMU, Rocket, and we're working on a feature where we will actually be able to implement custom drivers as well in the future. But in this example, I'm just looking at a Docker, and we'll have a look at a binary in a little bit. So I have a config stanza block, and the config stanza block is specific to the driver. So in this instance, I'm specifying an image, and this is just a simple little test server that I have, simple little HTTP web server. It's running in a Docker container, and I'm specifying some arguments. So the arguments that I'm specifying are my metrics collection endpoint, the version that I want to run, and I'm just passing in the Nomad's allocation ID so that I can show that in the output. But what you can see there, and if you've kind of looked at a Terraform before, but you've got a similar concept. So you've got interpolation syntax. So dynamically, Nomad is going to replace this Nomad IP HTTP with the node's IP for the HTTP port, which I haven't yet defined. And it'll do that specifically on every node that this group is placed on. So it's going to be very dynamic. It's a kind of a really nice little feature. So let's progress. So a task. Now, a task needs to be able to specify constraints. So you can specify your constraints, such as the maximum number of resources that it can use. So these are your C groups in Linux. I can specify that I want a maximum of 100 megahertz of CPU, which is about a tenth of a core. I'm going to specify that my job my task can consume a maximum of 64 megabytes of memory. And this is a super light little Go binary, so that's more than enough. And I'm going to specify that it can use a megabit of network, and I'm specifying the port. So I've got the port map inside of my driver, and what that's for is that's specific to Docker. So that's saying that map Nomad's HTTP port to port 8080 inside of the container. In my resources, I'm specifying a port of HTTP, and it's blank. I don't have a value. And the reason for that is that I want Nomad to just dynamically allocate me a port. If I just quickly go back to my system job, if I specify the static keyword inside of that port definition, then I can specifically tell it that I want this application to be running with port 8126. So I specify that in my resources because I don't want Nomad to try and place two applications on the same node which are using the same port, because it would be reserved. So that's really useful. That helps us with bin packing to help get the maximum of the utilization out of a cluster. But one of the problems that you face when you're dealing with these kind of highly distributed systems is that, well, applications are transient. Nodes come up and go down. Applications restart and they move around. And you need a method of service discovery. So this is a fairly common problem with distributed systems. And Consul was designed to solve the problem of service discovery. And I'm pleased to tell you that Nomad works really well with Consul. So if I want to specify service registration for my application, all I need to do is add the service stanza. And then in the same way as I can configure service discovery, service registration with Consul, I can just specify all of that information inside my job file. So I can say that I want to check, I'm registering port HTTP, the name that's going to show up in the Consul service catalog. I'm specifying some tags, and then I'm specifying a health check. So it's an HTTP health check running on the HTTP port. So that's the port that Nomad is going to allocate. 10-second interval with a 2-second timeout and my path. So if you're familiar with Consul, it's basically exactly the same settings that you might use if you're using something like an autopilot pattern or something like that. So let's see if I've made any typing mistakes, and let's run that job. So running a job is easy, super easy. Let me just change to the right folder. I do Nomad, run, and what I'm actually going to do, which I forgot, I think. Did I forget to save that? Is app.hcl, so that's the name of the file I've got. So I'm going to run that. It gives me some output to tell me that it's running some allocations, and then we can have a look at the UI to see that this is all running. So this is like that scheduled that incredibly quickly. I'm just going to drill down into there. We can see that we've got 5 allocations, and that corresponds to the count 5 that I specified for my group. And let's just click on one of those allocations and dive in a little. So I can see the UI is reporting the dynamic port that it's allocated. I can actually click on the logs, and then I can see the logs are displayed there. So really nice from an operational standpoint. Now what I want to do is I just want to start putting some fake traffic through that. So I'm just going to use Apache Bench to push some traffic through, and then hopefully we'll be able to see some stuff coming through. So we can see immediately that we've got some data that's coming through in Datadog, and it takes a little while for this to update. But what's the next most common thing that you're going to do with your application? I mean, if you only ever deployed them once, it would be awesome, but it never is. You're always going to be continually updating your applications. And Nomad makes that actually really, really easy for you as well. So what I could do is I could update that version there to 1.1, and I can run my job again, and it'll update the application and automatically deploy it. But if I did that just the way that I've got my job configured right now, then I'm potentially going to have a problem. And the problem that I'm going to have is that I'm going to tell Nomad that I want you to replace that job that task and that as quickly as possible. And it's going to go and do that. And that can potentially cause downtime. So as a strategy, what you want to do is actually do a rolling update. I want to be able to update those containers one by one, slowly, and I want to be able to check that they're healthy before I continue. So I can do that with Nomad because I can use the update stanza block, which looks like this. So what I'm telling Nomad now is that whenever I update a job, I want it to update it one at a time, and I want it to wait 10 seconds to confirm that that container is healthy before progressing with the next one. And this is fully configurable. There's a bunch of different options that you can do in setting there, including a really sweet option which allows you to automatically sort of roll back if it's going to fail. Where is that update stanza? So there we go. And this is all defined in the docs. Really, really, really cool. So let's run that. So again, I'm just going to check that I saved that because I can't remember. I'm going to run that. Oh, but I'm getting an error. So this is really useful. So I'm running this through the CLI, and I'm immediately getting an error telling me that group update invalid key health deadline. So it's telling me that I've got a problem with my Nomad stanza, and it's telling me that I've got a problem with this key here. The problem with this key is that I've spelled healthy wrong. So if I change that, correct it, run it, and off we go. What you'll be able to see is that this is slowly going to start updating the application to the latest version. So again, we can see that in the UI, we can see that it's placed 2, and it's slowly going through and replacing those instances. And that's going to take, what did I define, 10 seconds? I've got 5 jobs, like 50 seconds or something. But we'll move on while it's doing that, because actually it's going to take a little while for our information to come through in Datadog. Well, actually you can see straight away that Nomad is doing that. You can see that the requests, we've now got some requests running version 1, some requests version 1.1, and that dark blue is going to get larger and the light blue is going to get smaller as that job progresses, and that sort of migrates over to the latest version. So, I mean, that's a really nice way to be able to do things. That's pretty standard, right? Rolling deploys. But one of the things that you might want to be able to do, is canary deploys. So what's a canary deploy? Well, a canary deploy is when you add additional resources which corresponds to your new version, but you don't remove the old ones. So you leave the canary in production and you run the 2 versions of your application side by side for a period of time. You monitor it, you check it, and you make sure that everything's fine before you approve the roll through. So I can do canary deploys with Nomad. I'm going to add 1 canary to my job. I'm going to update my version there again. I'm going to remember to save it this time. And I'm just going to run that job. So that's running. What you can now see in the output there is that I have 1 canary. Eventually we'll see that come through in the logs here, sorry, the metrics output. But what I'm going to be doing now is, as an operator, I'm going to be monitoring that canary. I'm going to be looking to make sure that there's no higher levels of errors coming from that particular version that's being deployed. I'm going to check that it's healthy, and then I'm going to be satisfied with it. And once I am happy and once I'm satisfied, I can promote it. So I can either use the CLI, like I'm going to use, if I could type clear, going to do now. So I can do Nomad job, and then I'm going to do promote, and then the name of the job. So what Nomad is now going to do is it's going to promote all of the, all of those in that job to the latest version. And it's going to do it using exactly the same rolling update policy. So rather than using the CLI, again, we've got that API you can use to be able to do that. So if you wanted to have an automated thing using your metrics and monitoring, maybe from Prometheus or Datadog, then you can hook into the Nomad API to do that. I didn't show you this, but I've got console running here, and you can see this is my test app, which I've got. This is the one which is currently getting updated. And you can see that when I'm doing that, Nomad is automatically updating the service catalog and console for me as well. But let's have a look at some good stuff. So this is the part of the demo where I really need help from the demo gods. Because what I'm gonna do, whoops, wow. If my computer hadn't frozen. So I did say I was going to need help from the demo gods, right? And help from the demo gods, I really need. Bear with me 1 second. And let's just hope. I'll make that bigger in just a second. Cool. If I can just remember to make that bigger. Okay, cool. So what I'm going to do now is I'm going to have a look at how you can join two clusters together. Because what I've been showing you up until now is my cluster which I've got running in AWS. But I've also got a cluster running over in GCP. So what I can actually do with Nomad is I can federate these two clusters. So I can join them together, and that'll give me the ability to operate them as a kind of a single mega cluster or an Uber cluster. So to do that, it's really, really simple. So let's just have a look at my existing console. And you can see I've got a bunch of members there, which I've been playing around with this today, so I haven't cleared that out. But what I need to do to federate the cluster is two commands. Now I'm going to show you these on the command line. You would most likely do this through Terraform, but all I need to do is console join WAN, and I need to give it an IP address of a server which is running in a different region. So you can do this either, I'm doing it from AWS to Google Cloud, you could do it the other way around. How these are working is that I've got the two clouds connected with a VPN. So the only traffic that's flowing over the VPN is this gossip traffic that Rob explained in his intro there. So if I look at console members, and then I specify the WAN, I've got all of that sort of joined together now. So what I can also do is do the same thing with Nomad. So Nomad, exactly the same thing, Nomad server, join, and I specify an IP address of a Nomad server that's running in Google Cloud. That's running. So now when I do Nomad server members, what you can see is I've got 4 servers now. So I've got 3 in GCP and I've got 1 in AWS. So you can see on the right there that you have the region. I've got region AWS, region GCP. I've put them all in the same data center, but again, this is completely configurable however you want to cut it up. So let's see how easy it is to deploy a job to GCP. So I'm not going to change any of the settings for my Nomad configuration. So I can run Nomad status. That's going to give me the attached region, which is AWS. I can run Nomad status region equals GCP. And I've got no running jobs currently in GCP, but I can configure that up like that. So let's run a job over there. So rather than running the same job, why don't we have a look at running the same job, but just as running as a binary? So again, this is going to use fork exec. So everything's going to be C-rooted, but we're basically just going to run an application binary. And it's a Go binary, so it's statically compiled, statically-ish compiled. So it only has a single artifact. So what I'm doing here is I'm introducing to you another stanza. This is the artifact stanza. And this is part of a job, but it allows me to specify a source and a destination. So what I'm telling it here is when I run this job, I want Nomad to fetch test server from the URL there. And this is, again, configurable. You can use S3 buckets, you can use tars, zips, a number of different sources, all in the documentation. And I want to put it in the local folder. So the local folder without any prefix is going to put it into the allocations sort of temporary file source. Then to run it, I'm specifying driver exec, not Docker this time, and I'm setting some arguments. So these are exactly the same arguments that I was running before. Same resources, same service. Really, really easy. So should we run that? Well, let's run it. Now, what I could do is I could just do Nomad run, name of the job, and specify region GCP. But this is a great opportunity to introduce you yet another feature for your workflow, which is Terraform. So if you're already using Terraform, then Terraform actually allows you to be able to deploy jobs to Nomad. So I've got the provider, I'm just specifying an address, and I don't have a Bastion host for my cluster. So what I'm actually doing is just using an SSH tunnel. So I've got my local port 5646 mapped to Nomad's port 4646 on my host, and I'm just using an SSH tunnel. I'm going to specify the region as GCP, and then I define a resource. So this is Terraform. If you're familiar with it, it'll look very familiar, hopefully. But to actually deploy an application, it's really easy. So I create my job resource, and then I specify the job spec. And the job spec is just pointing at my HCL. So because it's Terraform, you can use templates and all sorts if you want to, but I'm just going to pick up the contents of that file. So let's just change folder, Terraform, application, Terraform plan. You can see that Terraform is reporting that it's going to create a new job for me. I'm not outputting that plan. I know it's bad practice, but I'm cheating a little bit. But I'm just going to Terraform apply that. And you can see that Terraform is going to schedule that job in Nomad. So again, Nomad status region equals GCP. And then I've got my binary application is now running there in my GCP region. No real complicated configuration. Everything just automatically joined. I've got 2 very quick minutes and I want to show you TLS and how TLS works. But let me just see if I've got time to show you just how easy Nomad can scale. So if I go quickly into my auto scaling group in AWS, and I'm going to find my clients for my auto scale group. I'm going to go to where is that setting? Edit, there we go. My setting, and I'm going to change the desired. I want 8 nodes, and I'm going to save that. So I've just changed my auto scale settings there. And once that auto scale group starts to kick in, what you're going to start to see is that AWS is now going to start creating new client nodes for me. I don't need to do anything to get those to join the cluster. Everything is auto joined using cloud metadata. So nothing clever to do there. And while it's doing that, assuming I managed to get that setting right, oops. Let me just double check that. I'll quickly show you. Oh, damn you, sorry. Oh, sorry, look at that. I've got my max there. Can't even read the error message, right. So while that's creating those additional instances and they're going to go ahead and join the cluster, let me quickly show you how do you configure your services with TLS. TLS is really, really, really easy. So because you've got console, because you've got Vault integration, and because they work completely seamlessly together, then what you can do is you can actually add a couple of extra stanza blocks. So what I'm doing is I'm adding my Vault stanza block, and that's dictating that this job, this particular task can use the policies, well, my policy. I'm not going to go through setting up Vault and TLS and how you configure the PKI, but the documentation for Vault is incredibly good for there. But the concept is that I have a policy which allows me to access certain secrets. So again, I'm going to use a template stanza block. And a template stanza block, if you've used console template, has got exactly the same capabilities. So I'm specifying that I want to get the secret from PKI issue my role, which is going to give me an X509 certificate. And I want to store it in secret cert.pen. And I can specify all of the features and capabilities that I would have with Vault. I could also be doing this if I wasn't using Vault, as Rob mentioned again, with my configuration and console. But those 2 simple stanza blocks. What I also need to do is I just need to update my application because I need to add a couple of additional attributes to that so that this application is going to pick up my TLS certificates and start in TLS mode. Oh, and I need to update my version as well. And sorry, change my folder. So that's going to run. So while that's running, let's just have a quick look at the Datadog. So what you can see here, the changing in colors is Nomad gracefully rolling through the different versions. So it's not doing an all replacement. We defined that we wanted to do little by little. What you're seeing here is the canary, because we told Nomad that we wanted to add additional capacity that we would run as a canary, and then we told it to promote it. So it started to run all the way over to version 1.2. And again, you can kind of see the number of containers which are starting and how that's staggered. And no 500 errors from our load balancer, which is always nice. So if I run back to my job, and of course, because I specified, I left the canary in there, Nomad job promote test app. We're nearly done. Yeah. Of course. Well, it's never going to be healthy because I didn't change the health check to use HTTPS. So let me see if I can find that job. But anyway, you can see there through this log that I'm actually trying to check, do a health check on a TLS endpoint with HTTP, which is never going to work in a million years. And that will go through, and you can see that it's picked up the certificate anyway from Vault, and it's now TLS secured. And I've got to do nothing there. The benefit of using that stanza block and template is that I can issue really short TTLs on those certificates, 24 hours or less. What Nomad is going to do is Nomad is going to automatically pick those up, and it's going to renew those for me. So I don't need to do anything. You can see here, these are a couple of extra settings for my service stanza block, which means that I can use tell console to check protocol HTTPS. I can tell it to skip verify, but actually if I configure Vault to use a CA, I can actually deploy that root certificate to all of my Vault my console clusters, so I don't need to use TLS skip verify. And that's it. That's the end of my demo. I hope I've kind of thrown through some really quickly some of the features, but I hope you can see the power of Nomad, and it's actually really easy to use. I mean, if somebody like me can do it, then it's got to be pretty easy. I think we've got some questions, Amanda.
Hi, Nick. Yeah, so we have quite a few questions. We're not going to have time to get through all of them, but we'll answer as many as we can. And for those of you that have a little extra time, we'll probably go over a few minutes today to get through some of those questions. So, Nick, one question that's come through a few times is people are complimenting your ZSH theme and asking about it.
Okay, so I use, it's a real Frankenstein of a setup. So I'm currently using Kitty, which is a GPU-enabled terminal, which is like just super quick for Vim and NVim. I also really like Alcatrity, which is another GPU-enabled terminal. But basically, what I recommend everybody does is go to github.com/Nicholas Jackson, and I think it's dot files, DOT files, and we'll paste that in. But you can see my dot files in there, and I use like Nord as this theme and all sorts of good stuff. But okay. Yeah, dig them out of there.
Okay. Next question is, someone's wondering if it's possible to deploy a Rails monolith application with Nomad, like without Dockerizing it.
Yeah, you could. So you could use the same binary method that I was showing earlier. You can prepare a node in advance that has the Ruby runtime installed already onto it, and then you can use constraints to target that particular node just for your Rails monolith. Totally possible to do that, yeah. And the combination of the fork exec and some templates and stuff like that, yeah, you'll get that up and running.
Okay, great. And next question, can you use Nomad to run a jar application without Docker?
Certainly can, 100%. Again, the Java actually has its own driver, which is completely configurable. So you can use the Java driver. The Java driver, I think, is automatically going to target a machine which has got a JVM installed. Really easy. Check out for both those questions, the drivers section of the documentation. So it's fork exec and the Java driver for those two, but totally possible. A lot of people are actually doing that with Java.
Awesome. Okay, next question. Someone's wondering if Nomad, does Nomad replace using things like ECS or Kubernetes to orchestrate containers?
It's complementary to them, or it's kind of so it's the same thing, right? So with ECS is a scheduler, Kubernetes is a scheduler. I would say the main difference between Kubernetes and Nomad is that Kubernetes does more than just scheduling. You've got the capability of configuring networking, and you've got some secrets management there. You've got some ability to do things like creating application load balancers in cloud. The way we look at that is we look at the Unix philosophy. So you have Nomad, it's a pure scheduler. You've got Terraform, there's your infrastructure management for potentially manipulating firewall rules or for manipulating load balancer. You've got Vault, which is your capability to provide and store secrets, but also for PKI sort of TLS certificates, X509 and stuff like that. So they're not competition. You know, each has its own purpose, but in my humble opinion, Nomad and the HashiCorp suite I find it the easiest to use. And obviously I wouldn't, you can trust me.
We like the HashiCorp tools.
I do.
Okay, and next question. Someone's asking if it's possible to target GPUs as part of the constraints stanza.
Yeah, it is. So what you can do in that, I'm not sharing my screen, but there's a whole bunch of different options. You've actually got cloud-specific options, so you can actually target a particular machine. If you're using, for example, AWS, you could say, I want to target I can't remember the names of them, like a T4XL or a particular GPU instance. There's a huge amount of configurability around those constraints, but absolutely possible for GPU. A lot of people do that for data processing. They're going to be running the TensorFlow and stuff like that. They want to run it specific on a GPU instance.
I can add a bit to that as well, Amanda. So there's a concept of node meta tags in Nomad, where you can assign just arbitrary metadata to your clients. And so you can reference those meta tags in constraints in your job files if you want to kind of do some sort of a manual kind of ability to kind of target GPU capable nodes. The other thing I wanted to mention is first class GPU support is very high on the roadmap. And so GPUs will become a resource that is first class in the job spec that you can actually request, just like you can memory and CPU and network.
Okay, awesome. Thank you, Rob. Okay, and kind of speaking of AWS, you mentioned that, Nick. Someone's asking if you're running in both AWS and an on-prem, say Ubuntu and Docker containers, would the Nomad server run in AWS and then each physical server in each data center be a Nomad client?
Maybe. So generally what you would do is you would split your servers across, I might be misinterpreting this question actually. So you can have multiple servers running in like the different regions in AWS. You could have servers running in AWS and client nodes running in your own private data center. You could have them running in GCP. It's really, really flexible. I mean, Nomad kind of, as long as the servers and the client nodes can talk to each other over their RPC protocol, which is, I think, port 46, 47. There's a very few number of ports anyway. It's very, very, very configurable. You can kind of cut things up however you want, and it's very easy. I've got a Raspberry Pi setup, which is running on my desktop here, and I've got a VPN. So I often will spin up servers in the cloud, and I connect that up to my local Pi cluster. It's like super easy to do that. Again, cloud metadata and all that.
Okay, awesome. So then now the next question is, does Nomad handle auto scaling of nodes if a container needs to scale to more hosts?
So we don't directly. However, there are at least 3 open source products. So there is the one I recall off the top of my head is Replicator by Elsevier. And what Replicator will do is it's a simple application which you run on your cluster, and it will scale horizontally and vertically. So it's auto scale aware. It will increase the number of nodes if capacity is exceeded. It's also application aware. So if an application needs to scale, so increasing the number of instances of it, it will do that too. So whilst they're not HashiCorp direct solutions, they are battle tested and production worthy solutions. So Replicator by Levant and by Elsevier, and I think there was Rob might know the name of the other one. It's like
Under Armour, I believe, open sourced a project called Libra, which is the other big one. And Spotinst, which is a technology partner of ours, also I believe has some sort of autoscaler as well.
I knew it was a big company, yeah.
Yeah.
Okay, awesome. And then we'll probably just take like 2 more since we are over time. Nick, someone's asking if Nomad supports blue/green deployment.
Yeah, so the Canary deploys that I was showing earlier, you can use to use that technique for your blue greens. So you can just specify that you want X number of containers or X capacity over. You run the job, you monitor it, and at the point that you're happy that you want to switch blue to green, you just run Nomad job promote, and that's going to automatically transition over to the new version. Likewise, if you're not happy, then I can't remember what the command is, but it'll be like whatever the opposite of promote is, demote. But you can roll it back anyway, so you can get rid of the new version and push it back to the last known good state.
Okay, great. And then another person's wondering if there's support for persistent storage. They're kind of saying, similar to stateful sets or persistent volumes in Kubernetes.
So not directly out of Nomad, but again, there is Storage OS will work with Nomad. Is it Heron, Rob? Or I forget the name of the...
Yeah, I think you're thinking of Portworx, the storage volume management tool that you can run as a system job across the Nomad cluster. Yeah, and you can do inline volume creation with that. I had also mentioned that the Docker driver supports volumes. So if you have volumes that are already exist on the host, you can mount those into the container if you're using.
And there's also ephemeral disks as well, so that you you can specify that Nomad will attempt to move an allocation folder as and when across, I think.
And then finally, but first class support for persistent storage volumes is very high on the roadmap, something we're going to tackle this year.
Yeah, there's some great stuff coming down the road.
Yeah, we have a busy roadmap. Okay, and then I think this will be the last question, Nick and Rob. So someone's saying they notice there's no explicit cleanup. So they're asking when a job is stopped, what's the best practice for running cleanup tasks at the end of a job?
So Nomad will garbage collect. So it will clean up any of the allocations which are on the nodes sort of periodically. You can also run Nomad stop -- purge, I think it is, and that will explicitly go ahead and clean things up.
Okay, so then I think that will wrap things up unless, Rob, there's any other questions you think, anything else you needed to add.
Oh, I just want to show one thing. So someone was asking a question about dev clusters.
Yes, Nick,
So
yes.
for running a dev cluster, a single Nomad server is perfectly serviceable. I mean, it's completely stable. It's not production workload, so you don't. But what I do, you can also, for dev cluster, is you can run the server, and this is going to, I'm running, you can run a server and a client on a single node. So what I've got here are 4 Raspberry Pis, and I've got my little Nomad console Vault dev cluster, which is running on the Raspberry Pis. So it's really, really easy to do, and it works perfectly fine. So if you want to save a little bit of money on your sort of dev clusters and just have a single node for a server, but you obviously accept the risk that it, well, you've got no replication on that, then yeah, no problem at all. Really
Yeah.
easy.
Okay, thank you, Nick.
Oh, you can also run it on your laptop locally as well in both single binary, and you can run it in dev mode, which means it'll be a client and a server running on your laptop. So if you want to play around, really, really easy to do.
Awesome. Yeah, actually, Nick, someone asked about that, if you were running Nomad locally or if you were deploying your job to a cluster of clients.
Yeah, I'm running it. I'm deploying everything. I'm running the CLI. I've got the binary installed locally, but no, I'm deploying absolutely everything to AWS and to GCP.
Awesome. Okay, thanks for the clarification. All right, sorry we went a little over, but hopefully everyone enjoyed the extra time of Q&A. Those were lots of great questions from the audience. Thanks for everyone's contributions. And I hope you all enjoyed today's webinar and you were able to learn a bit more about Nomad. Thank you for joining us, and a special thank you to Nick and Rob for their time today. And finally, as I mentioned at the beginning, this webinar was recorded, and we will make the recording available on our website after processing. I'll send an email out to all of you and everyone who registered with the recording link. You can also keep an eye out on Twitter. I'll post it on there as soon as it's live. Thank you, everyone, and have a great day. Goodbye.
Thanks very much. Later.